Rudolph Technologies Auto EL4 with NIR3 option. So this system has a motorized stage. The stage should never be disturbed from its condition. In order to move the stage, the joystick can be used. Once the system is powered up, the stage initialization takes place. So there is a sensor here that senses the stage movement and position. The unit has two arms. One is on the polarizer side, which is on the left hand side, and the analyzer on the right hand side. The polarizer arm has a lamp source in it, which is a tungsten halogen bulb. And at any point of time, the angle of the incidence of the light on the sample can be changed by pulling out the lever and rotating the whole arm. Both arms should always be at the same angle. Currently, this is set up for 70 degrees. This end piece on the autocollimator can be slided out to view the image of the sample. So this tower becomes a microscope. So it can view through the eyepiece here. The unit will be shipped with the stage lowered for shipping purposes. And after receiving, the system should be level using the two knobs underneath the stage. There is a big dial at the bottom of the stage. There is a quarter 20 Allen screw here under that, which is to be loosened, and then we rotate the knob in order to raise up or lower the table. And the two knobs on each side, the left hand side and right hand side, and there is a knob on the front. These three knobs are used for the autocollimator alignment. The autocollimator adjustment is to be done by turning on the ACT lamp on and viewing through the eyepiece with a sample on the stage. There is a bright dot which is to be at the center of the crosshair. I'm going to demonstrate the autocollimation adjustment once I load the sample. After power up initialization, the system stage initialization takes place. After the stage initialization, the system prompts with to insert sample and continue. So at this point, we insert the sample and press continue. While the stage is moving, locate the sample at the right place so that the beam, the bright dot from the polarizer end, bounces off the sample and enters the nose piece on the analyzer head through the aperture at the center. So the Z-axis adjustment has to be done in order to make sure the reflected beam is passing through the center of this nose piece. And looking through the eyepiece here, the left and right knobs can be moved to move the dot horizontally, and to move it vertically upward, the front knob is to be used under the stage. So once the alignment is over, press continue. The unit will prompt with version control number. In the manual, it is described the various software options available against each number. Right now, the polarizer and analyzer side motors are spinning to locate the beam null position. So once the initial nulling is over, the system prompts for run or learn. If there are preloaded pre-programmed recipes in the system. Program 20 and 21 are for silicon dioxide on silicon wafer. Program 20 will measure both refractive index and thickness of the film, the upper film. And program 21 will only measure the upper film thickness. So this system, the motorized stage, has another option of pattern. So in the manual it is given various pattern numbers are available. If multiple points are to be measured, different pattern numbers can be chosen, whether 5 point or 10 point like that. And pattern number 20 will measure the film thickness at the center of the wafer. And I'm going to start with program 20 and enter. The sample specimen thickness is expected to be entered at this point, otherwise the default value of 1000 will be taken. This is 1100 angstrom sample. So once the values are entered, the parameters will be printed on the thermal printer here. So the unit will change the wavelength to the wavelength equivalent to helium neon laser, that is 6328 angstroms. The other two wavelengths available are 8300 angstroms and 4050 angstroms. Depending on the sample and depending on the requirement, any wavelength can be chosen. The refractive index of the upper film should be entered in case of samples other than silicon dioxide. The unit now displaying the TU, which is the thickness of the upper film. The measurement is completed. The upper film thickness is displayed as well as the refractive index. The unit measured and is now displaying 1.462, which tallies with the silicon dioxide value. Now I'm going to run a different program, number 21, and here the sample thickness, and then the upper film refractive index is 1.462. The default value also may be selected. Program numbers 0 to 9 can be selected in learn mode and teach the unit the substrate parameters and the film parameters, and also select the required wavelength. The unit will measure for customized samples, provided the optical constants of the film and the substrate are available. Now I'm going to change the sample to a different film thickness, which is of the order of 2200 angstroms. In order to measure the refractive index of a film, the film thickness should be at least 1000 angstroms. The measurement will be accurate when it is 1100 angstrom thick film. ROEL 4 can measure and display the thickness values about the ore thickness. For this unit it is 2825 angstroms. So the measured thickness of the standard is 2256 angstroms, which tallies closely with the actual value of 2236 angstroms. I have a sample here with about 9000 angstrom film thickness. I want to measure it. At any point of time, to interrupt the recipe running, we can use the key escape. To initialize the system, the reset button can be used. The photo detector here is a PMT tube, and care should be taken. There are high voltages on the unit. So the thickness measured is 9489 angstroms, which is pretty close to 9470 angstroms, the actual sample reading. That's the bright dot. Right now I'm moving both the right hand side and left hand side knobs and moving the dot left and right, and then loosening the front dial, the dot goes up, and tightening it brings it to the crosshair.